Today we are going to see an introduction to systems programming. This subject is studied by second year students, engineering students. And the textbook which is used is System Software, an Introduction to Systems Programming by Leland Beck. So we are going to see some topics over here in this video. Systems programming. The first chapter deals with the background. Second one deals with the assemblers. Third one is with loaders and linkers. Fourth one deals with the macroprocessors. And the last topic is the references of this topic. So we are going to see the background of the. So we are going to see the introduction for this subject. Then we are going to see what is system software and machine architecture. Then we are going to see a hypothetical machine called SIC. The long form of SIC is Simplified Instructional Computer. And there are two versions of SIC machine, that is SIC machine architecture, and second one is SIC XC machine architecture. And we are going to see some programming SIC as well as SIC XC programming example. So we are going to see an introduction to this system software. So system software consists of variety of programs and which will help to support the operation of a computer. Using system software only, we can interact with the computer. These programs are implemented either as a software or it is implemented on the hardware. So it can be a software or it can be a firmware. And using this, it makes the hardware we can use the computer to use. So systems software makes possible for the users to focus on an application or the problem to be solved rather than needing to know the details of machine, how it works internally. The user need not have to bother about the inner details of the machine, how the program will be executed internally. He has to only focus on the application or the problem which is to be solved. So for that the system software helps the user. So the user need not bother about the inner details of the machine, how the machine is working with respect to his program. Then we are going to see BIOS, basic input output system. So these programs are written on the hardware, and when the system is switched on, when the computer is switched on, these programs are executed and it enables to use the system. It makes to use the system, or it initiates the execution of the program which is present in the hardware, in some of the hardware, like this BIOS is present in ROM. Now we are going to see the difference between system software and application software. One of the main difference between system software and application software is system software is dependent on the machine architecture, whereas application software is not dependent on the machine. System programs are which helps, or it is built to support the operation of the computer, and it is not built for a particular application. So application softwares are built for a particular application, whereas system softwares are built to support the operation of a computer itself. So there are different types of system software. You can have text editor, assemblers, compilers, loaders, linkers, debuggers, macroprocessors, operating systems, database management systems, software engineering tools. All these are the different examples of system software. Now we are going to see what is this system, what are the different kinds of softwares system softwares we have. One is a text editor. So what it does, we use this text editor to create a program, and you can modify your program using this text editor. We have already seen some examples. Those are Microsoft Word might have used for creating our document, or we create a text file, or in Unix or Linux operating system we use this VI editor or Vim editor, we use gedit editor. All these are different kinds of editors which helps us to create a program, and you can modify using this text editor. The second topic is compiler and assembler. These are system software. Compiler, what it does is, it takes the source program which is written in some language, or you can say high level language or middle level language, and it generates the object code. The object code is a binary bit pattern. And assembler, it takes the input which is written in assembly language, written in assembly language, and it generates the object code. So there is a difference between compiler and assembler. Compiler takes the source program which is written in any of the high level language, and it generates the object code, whereas the assembler takes the assembly language code and it generates the object code. Next system software is loader or linker. This loader or linker, or these system software help us to load the machine program which is generated by compiler or assembler. It helps the object program it helps the object program to load into the main memory, and it initiates the execution of the program. So the loader which places the object program into the main memory, and it initiates the execution. Similarly, linker is a system software which links the different object programs, and together these object programs are loaded by the loader into the main memory, and then it initiates the execution. The next system software is debugger. Debugger which detects the error in the program. So we are going to see the system software concept. So we can see here a layered architecture. So in this case, the bottommost layer is bare machine or the computer hardware. On top of that, we are having one layer, that is operating system, which consists of 4 sub-modules. Those are memory management module, then processor management module, device management module, information management module. So operating system directly interacts with the bare machine of the computer. So this operating system, which is also called resource manager. So it manages 4 types of resources. One is memory, second one is processor, third one is device, and fourth one is information. So it manages the memory in the sense it manages the primary memory, secondary memory, how much memory should be allocated for the user program, and when the user program execution is after the execution of the program, it deallocates the memory. So allocation and deallocation of the memory is performed by memory management, and it is the part of operating system. Similarly, processor management, which again there are 2 types of processors, or you can say processor or central processing unit, which all the instructions are processed by this processor. So this is managed by the operating system. And third one is device management. So there are several devices which are connected to the computer. So input device, output device, all the peripheral devices are managed by the operating system. Then you have information management system, which consists of all the file systems in the computer. So operating system acts as a resource manager, and it manages 4 different kinds of uh, resources. One is memory, second one is processor, third one is device, and fourth one is information. On top of operating system layer, we have compiler, assembler, loader, and linker. So compiler, which generates the object code for the higher level language program, then assembler generates the object program for the assembly language code, then loader places the object program into the main memory and initiates the execution, then linker, which links the different object programs, and then the loader loads this linked object program into the main memory, and then it initiates the execution. So compiler, assembler, loader, and linker, these are the programs which are above this operating system. The next layer is debugger, macroprocessor, text editor, utility programs. So debugger is a program which finds the bugs or the errors in the program. Macroprocessor is another system program which helps us to substitute a set of instruction wherever we are going to have a shortcut notation for a particular set of instruction, and thereby writing the program will become more easy. And this macroprocessor processes this giving a common name, and then it is going to expand these macros which are defined in the source program. So that is the work of macroprocessor. And next one is a text editor, which enables us to create a program and modify the program. Also we have utility programs which are library functions. On top of that, we have the user or application program. So application program, depending on the application, we are going to write the application program, and this application program are used by the users. So users who use the application programs uses debugger, macroprocessor, text editors, and utility programs, and these debuggers, macroprocessor, text editors, and libraries are used by compilers, assemblers, and loaders and linkers, and these in turn are acting with the operating system, and operating system is directly interacting with the bare machine. Okay, so the next topic is system software and machine architecture. Machine architecture. So we are going to see what is a machine dependent. So when you have the system, which is when you have the architecture, when it is developed, let us consider 8086 or Intel 8086, Intel 8088, Intel 286 or Pentium machine. All these are different architecture. Z80, all these are different architecture. So when you are going to write a code for these machines, okay, so these are writing a code for these is a machine dependent. So machine dependent in the sense, depending on the architecture of the machine, you have to write the code, and that is called machine dependent. So so when you are going to say machine dependent code, that means you should know the set of instructions. What are the set of instructions we are going to have for that machine architecture? What is the instruction format you are going to have for that machine architecture? Then what are the different addressing modes we are going to have for that machine architecture? Then what is the assembly language code we are going to write a program for that architecture? So these are called machine dependent. Another thing is machine independent or general design or logic strategy. So we are going to have there are two types. One, when you say that machine independent, it is a general design. Okay, so we need to see a computer. With the computer in this diagram, we are going to see the computer which interacts with the machine dependent code, and this machine dependent code interacts with the machine independent code. Next one you are going to see what is instruction cycle. So what is instruction cycle? So when you write a program, those are the set of instructions in a program. So this program, when you want to execute, this program must be loaded into the main memory. Now when you load the program, user program into the main memory, you want to run the program. So for running the program, so to run, what do you mean by running the program? One by one the instructions are fetched from the main memory into the processor, and processor processes those instructions and gives the result. So we can say instruction, when you say a particular line is executed, there are two parts here. One is what is done by the processor and what is the instruction cycle. So what is there in central processing unit? It has three parts. One is control unit, second one is arithmetic and logic unit, and third one is registers. So these registers are used as scratch pads. That means the intermediate results are stored in the registers, and the processor is having its own registers. Any architecture will have its own register. Now, instruction cycle. So we are going to see there are two cycles for this instruction cycle. One is fetch cycle and second one is execution cycle. So what is fetch cycle? We are going to fetch one instruction from the main memory into the processor, and after getting that instruction into the processor, we have to decode it. That means we have to separate the operation part as well as the operand part. So any instruction has two parts. One is operation code and second part is operand part, address of the operand part. So this instruction, after fetching the instruction from the main memory into the processor register, that is called, usually it is called instruction register, and after that, that instruction must be decoded. When you say it is decoded, it is going to separate this opcode and from the operand part. This opcode or operation code tells that what is the operation to be performed. Example, add opcode, subtract opcode, multiply opcode, compare opcode. All these are different opcode. Opcode stands for operation code. Similarly, in the instruction, we have the other part called operand part. So that is, it is having the address of the operand. So any instruction will have two parts. One is opcode part and another portion is address of the operand. So that address of the operand is present in instruction. Now you have to fetch that operand for the execution purpose. So you are going to fetch the operand, and after that it is going to perform the computations. So after performing the computations, it is going to store the result either in the register or in the main memory. So these are the, you can say instruction cycle has got four parts. One is fetch the instruction, decode the instruction, fetch the operand, compute the operation, and then you are going to store the results.